turn on the transcription. Cool, so you should have the ability to turn on and off transcription now, if that's helpful for you. And yeah, I just want to do some like quick norm setting for having me as an instructor. You'll notice that all of us kind of have slightly different styles. For me, I'm okay with y'all kind of at any point you have a question or something comes up. I usually can like keep track of the raise hands feature pretty consistently, but if I like am talking and you can tell that I'm transitioning or moving on from the area where your question is and I haven't called on you, then feel free to unmute and be like, hey Tim, I've got one for you. I don't mind if you interrupt me. And yeah, I think like overall, like think of this as this should be interactive. Like I'm not going to try and I won't be talking at you. We'll all be doing things kind of like throughout the class. I usually take like I do a little, you do a little, rinse and repeat kind of approach to most of these lessons so that you can be getting the practice in that you need here. I think that's all. Any like questions about that approach or anything that is on y'all's mind, just in general that you wanted to ask about? Okay, so yeah, let's get it going. The lesson plan is in the calendar. We're going to start off with objects, instances, and classes. And we'll follow the lesson plan some of the time, and then I'll probably deviate some of the time and just ask y'all to do certain things. But yeah, I mean, let me share screen and have y'all follow along. All right, gotta organize these Zoom windows. Cool. Man, I haven't taught a Mod 1 class in like so long. It's exciting to get down to the fundamentals. And just want to like reiterate from y'all, like a lot of times when we teach this, based on y'all's questions, like we can learn something new. So I want you to think like, yeah, I know what's going on here, but also the more you can poke and prod at me and like what I'm saying and how I'm saying it, I think the better the experience would be for y'all. So thinking of objects, classes, instances, we need to like know one of the biggest things I feel like coming into programming is there's a lot of new language, right? Like there's a lot of new technical terms, and we need to harness those technical terms because looking all the way ahead to when you're interviewing for a job, that stuff, that like saying the right term in the right context matters quite a bit, and you'll have plenty of practice at that here. But yeah, we need to know the difference between these things. Today we're going to look at, you know, how we can create instances from classes, what exactly is an object, and spoiler alert, everything in Ruby is an object, and you'll probably hear us say that quite a bit, but that's kind of the design. That's how the language is written. It's fundamentally at its core an object-oriented language. So everything in Ruby is an object, and I'll kind of like show some examples of what I mean by that. But yeah, classes are generally going to have two things: state and behavior. So we need to understand the difference and understand how we can utilize state and behavior to kind of to construct our classes and then construct instances of those classes. Cool. So yeah, I wanted to, I don't know if I love this warm-up example, but I wanted y'all to just take like some time on your own. So we'll take 3 minutes on this. Write down in your notebook or in your notes everything you know about an instance versus a class, and an example of a class that you come up with that is not the example here. And an example of a class that you come up with, specific instances of that class, and then any attributes or behaviors. And we'll actually, I'm asking you all to do a lot. Let's take 5 minutes on this, and we'll come back and share out and talk about your examples. So we'll come back together at 11. All right, I'd love to hear what a few of y'all came up with. So yeah, let's hear from Ida first. What'd you write down?
I wrote down an automobile for the type of object, and then I wrote for specific instances, a farm pickup, a school bus, a rental convertible. And then for like attributes, I put like make, model, color, and then like behavior was like drive, reverse, neutral.
Great. Yeah, and that makes perfect sense to me. The one thing that I wanted to just correct was you said type of object, and so I would say that the type of class is automobile, and then the objects or instances that you're creating are the examples that you gave.
The type of class. Got it.
Yep. Cool. Yeah, let's hear from Tanner. What did you write down?
So I did for an instance versus class, an instance is a specific object from a class. And then for my example, I did like a drink class. So it has attributes of like, it has whether or not it's a liquid, a color, a flavor, like caffeine content, sugar content. Then behaviors, you can have like refrigerate or freeze. Then I had a get drunk one. So like you drink from it. Then potential instances like water, coffee, tea, Dr. Pepper, Coke.
Great.
Stuff like that.
Love it. Yeah, love it. Yeah, I don't have any feedback on that one. I think all of that makes sense to me. Yeah, I want to hear from one more person. How about Isika? And tell me if I said that incorrect, but I think I got it.
Yeah. It's Isika.
Isika,
So mine was actually, yeah, the object. I wrote down a car class, so it's similar to Ida basically.
Nice.
With yeah.
Cool. Okay, great. Yeah. So the example I like to use with this is the class we can think of as our blueprint, right? If we're thinking about like building a home, you can think of, well, you need a blueprint to figure out how this home is supposed to be built before you can actually build the home. But then the living representation of the home, like in the physical world, is the idea of like, that's the instance, right? And that instance may be slightly different depending on, how much flexibility that blueprint has, right? So, and we'll get into some more examples of that. But yeah, I like these examples that y'all came up with. Any confusion right now on like this idea of like, all right, you've said some words, object, instances, can I use those one and the same? Any confusion about the difference between a class and an instance? Yeah, go ahead, Matt.
I guess I'm just confused about when you would like just what it means for it to be object-oriented programming if everything is an object. Like what are the alternatives that we're trying to differentiate it from?
Yeah, that's a good question. So there are like other programming paradigms. The first one that comes to mind is functional programming, where everything's a function. And like, that's the idea of like, for Ruby, that would be like if everything was a method, but we didn't have classes. So that's like a totally different paradigm of like how some languages are built. Like JavaScript actually has the ability to be object oriented, and like that's kind of the general approach, but it could also be written functionally. So it can kind of be both. And then some languages are just functionally. And the idea with everything's an object is that everything in Ruby fundamentally like inherits from some class that has been defined by the Ruby language, and that we can create instances of, such as, I think this could be like a little bit better with an example. So let me just jump in real quick. So if I go into pry, and this is basically just like your Ruby playground. So you'll see us jump into this here and there. So if I assign, like, if we're building from yesterday, I assign my string to a string of Tim, great. Well, I can now say, actually, I kind of want to just do this right on the string. So if I ask this string, hey, what class are you? It's from the string class. And you can think of Tim as the specific instance of the string class. The string class has attributes, has behavior, has methods I can call on it, but it is a concrete representation of the string class. And if I look at, now I'll kind of like show you a little bit deeper. If I look at tim.ancestors, that's not what it is.
Kim, your
Yeah, go ahead.
font is really small on the screen. Can you?
Oh, thank
enlarge
you. Yep, my bad. Please let me know when stuff's hard to read. Is that better?
Yeah, that's much better.
Much better. Okay, cool. So let me, I can't remember what this one is. I think it's I promise we're going somewhere here. Oh, I think I need to call it on or on the actual class, possibly. Yeah, okay, cool. So I can't call ancestors on the instance of Tim, but I can call it on the string class. So that's what I need to do. So if I say, hey, and these are just methods that are available for any object. So you can always, like this dot class and then dot ancestors on that will give you, I'll just show you the hierarchy kind of Ruby. All right, so this is what I mean by like everything's an object. Like everything in Ruby inherits from a chain of other objects. And at the highest level is this basic object. And so this is like a fundamental or object-oriented programming paradigm inheritance. And so everything is inheriting from basic object at its core, like all the way up the chain, and it inherits from other things. So object is inherited. Comparable is actually a module, so I don't want to confuse you, but ancestors gives you all of the modules and the objects that it inherits from. But that's kind of getting kind of deep. I wanted to give you this example so that you can see, like, yeah, everything in the Ruby language is some type of object. And essentially that's what that means. So hopefully that was helpful. Was that helpful, Matt?
Yes, thank you.
For sure. All right, Ted, go ahead.
So I was wondering, so is instance and object, are they kind of interchangeable? Because you're saying that class is, you know, the whole thing, and then you kind of pass objects through the instances. Is that right?
Yeah, so you got that pretty much correct. I would say you'll hear us use object and instances interchangeably. The difference is that object can have more meaning than an instance. So when I say it's an instance, it's always I'm talking about creating some concrete representation from some class. But when I say object in Ruby, like I could be also talking about like, I mean, it's still a concrete representation, so we will use them interchangeably, but object can have a little bit more meat to the definition because everything's an object in Ruby. So like thinking of it that way is like, that's a little bit more abstracted, where when I say instance, I'm like, well, it has to be an instance of a specific class. So that's kind of the only real difference. And when I say instance, I'm like talking about, hey, Tim is an instance of the string class in this example. But when I say object, I could be like talking about like some other representation from in Ruby that's like I mean, it is an instance. I think for the sake of this, it's like think of them interchangeably and know that like object, you'll kind of understand more about, I think, as you create things and get a little deeper into this mod. Cool.
Okay.
Ida, go ahead.
Sorry, I didn't know my hand was up.
All good. Okay. So some examples there. And yeah, let's get into another example. So in the lesson plan, there's this dog example, and I was like thinking about building a dog this morning. So I wanted to like start with that. Yeah, first, so you can kind of see like in my terminal, I've like where I'm at, I created a objects, instances, and classes directory. And I've also like, if I open this up, I've also created a couple of classes and some files. I've got a file called class example, and my example here is a Turing instructor. I'm probably going to change that around real quick, but I want to just like point out some syntax real quick, get these controls out of the way. So at its basic form, a class will be created like this. Like you can think of this as the skeleton code for me being able to make instances of Turing instructor. So the things to look at here, class, oh, my bad. Is this, can y'all see this okay? Is this like too small? If it's too small for anyone, I always ask people to like zoom in. So I'll even just do this a little bit. Is that all right? Give me a thumbs up if that's all right. Cool. Okay, so things to look at here. The class keyword, and this is what we call this is a reserved word in Ruby. So Ruby interprets this, understands when you say class, and that's why it shows up purple in my editor, where if I typed something like this with an extra S, it wouldn't show up like this. That is a reserved word in Ruby. So Ruby starts to interpret that as a class. It says, okay, you use the word class. So whatever you type after this is going to be what you are defining this class's name as, and what you will like use to create instances of this class. So I have this like Turing instructor class, and notice that this is also kind of showing up in a different color. It shows up yellow. And the thing to remember here is we capitalize each word of our class. So lowercase on the reserved keyword of class. And then whatever we're naming our class, we call it, or we use capital letters. And this is like what Ruby expects. All right. So the reason that we do it this way is because this is the convention that Ruby has chosen and has told us to use. And so this is what we have to do to make it work. This will also work, I just want to say, but this is like, this breaks convention. So like if you did this on the job, people would be like, well, why are those two words not capitalized? That's convention. And you'll hear us like use the word convention a lot. Convention basically says, hey, we have enough decisions to make in programming. So the language has already made some of those decisions for us. And so this is one of them. Okay, any questions on syntax here? All right, cool. We'll create some instances here in just a minute. We've been going for like 25, so I want to give you all a 5-minute palm. Let's come back at 29.
Hey, Tim.
Hey.
I was just going to ask a question. The flashcard project that we were assigned yesterday, is that something that we're supposed to be kind of building on as we go throughout the week? Or, because I looked at it and I was kind of like, wow, I don't know anything in this.
Yeah, that's pretty much where I would expect you to be honest. is like, all right, I don't really understand what they're trying to ask us to do. And so like today and also like throughout the week, yes, like we expect you, like you're going to be learning stuff, and then you're like, okay, well, maybe I can take an approach to this area of the project, right? And so I don't really expect y'all, like that's a huge undertaking to build that entire project. And like you should still be trying things. Like it's okay. Like there's one thing that I always tell students is like there's no substitute for hours spent trying. So like just know that. And I don't expect y'all to have a great idea of how to build this, but hopefully one of the things that maybe comes out of this today is like you're like, all right, I feel like I can build some parts of a card class, right? Like I think I can maybe tackle that now. And like one thing at a time, like focus on that, focus on iteration 1, or it's probably iteration 0, I don't even know. And like go from there, because that's the whole thing. It's gonna, as you have classes, as you start to kind of like build up some skills, you'll be surprised with like how much you can do once that starts to happen. But yeah, I mean, you being like, I don't know what this is where I would expect you to be. Yeah.
Okay, yeah, because I looked at it and I was like, I'm gonna get started. And then I was like, nope. Okay.
Yeah. Yeah, no worries there. I think like what I will say is like, if you're not sure how to get started building a project, that probably means you need to do more reading and like research of like, okay, like they're asking me to do these things. I don't know how to do them. There's probably a lesson that I could at least like read and like take a look at, right? Even if it's before we've had it, because if you take a look at the lessons before we get here, then you'll come with like some questions, and you'll, instead of leaving with confusion, a lot of times you'll be able to clear up confusion. You'll come with confusion, right? And then you'll be able to clear that up via the class. And that's the hopes, at least. But that would be my approach, is like, all right, if I'm not able to actually build the thing, I need to go like read about how I might build the thing. Yeah. Cool. Ida, go ahead.
Could you please pass on maybe to Mike to tell us that, or tell the next group that when they introduce the project? Because what you just said was enormously calming, but he didn't really say that yesterday.
Yeah, I think that's I think you'll see that instructors have different approaches, and that is just part of this program. And mine is my own, so I can really only like take responsibility for my own approach. And like, you can get a lot out of, you know, an approach that's a little more like, hey, you're in the deep end and you got to go figure it out, because eventually like you have to do that anyway. And now what I'm saying is like, I think it's okay for you all to feel some angst and like some worry about, you know, what you're supposed to do. And that's what we're here. We're, at the end of the day, we are here to help kind of like clear up the confusion, put the ideas together, and go from there. So yeah, here's what I'll say. The worst thing you can do is not say anything. So I'm glad we're having this conversation now. We're talking about it, because the worst thing you can do is sit at home alone at your desk and be scared. And I've been there. Like I've been exactly in that situation. And it took me repeating a mod to like figure out like, all right, time to ask for help. So don't make my mistakes. Reach out today, tomorrow, every day, when you're like, hey, I'm not sure what's going on here. Here's what I think is going on. Here's where I'm confused, and like start the conversation, because the conversation happening, especially in that code help channel, is something that will accelerate the process of kind of like putting the pieces together. Cool. All right, so I got a nice chat message that let me know that Turing instructor is actually spelled wrong here. So appreciate that, Jimmy. And yeah, that's another thing I wanted to just call out. Like we're not perfect. Like I haven't looked at this repo in, I don't know, like over a year probably. But I mean, I taught this class over a year ago. And yeah, so instructor's spelled wrong. So at this point, if I want y'all to see this error that I would have got, because this is how I would have figured this out. I wasn't going to figure it out just by looking. But like, let's say I try to create a Turing instructor .new. If I try to create an instance here, and I'll just save this to a variable, instructor1, And the way that I can make this code run essentially is put that over there. And you'll see me like use a bunch of shortcuts and you're probably like, holy shit, that's fast. If you want to know what the shortcut is, just stop me and ask, because one of the most painful things for me as an instructor is like you get to mod 3 and you only are using your mouse still. And I'm like, come on, you gotta be faster. And really like fast, like pace is gonna, you can control learning shortcuts. Learning shortcuts, low lift. Learning how to write code, high lift. So make sure you get the low lift stuff done, because it's gonna help. It's gonna speed you up. Okay, that's my little shortcut rant. You'll probably hear some more. So if I want to run this file, and the way that I know I can run this file, it is, I am at the objects, instances, and classes directory. So if I want to run this class example file, I need to say Ruby class example.rb. And now I'll see what happens, right? Like, I don't know what's going to happen. What I hope that happens is, you know, okay, I mean, I know what's going to happen. I'm going to get an error. And so I want y'all to see that error. Cool. Let's make this a little bit bigger. Oh, come on. Why did that go away? All right. So uninitialized constant, Turing instructor, name error. Great. Where did that happen at? That happened on line 5 here in class example. So now that I have that, I can look, okay, it's happening here. And this is something that will happen to you in mod 1 as you define things and you make mistakes. Like, you're like looking at this and you're like, what are you talking about? Like, I have the class right above it. I can see it. And if you see name error, that should point you to like, okay, there's something wrong with the spelling here. Like, something is off. Like, Ruby doesn't know about the class that I think it should know about. And so the way that I could like change this and make it actually work is I could spell the class right? Oh, it's still not spelled right. Cool. And now if I execute this file, nothing happens, which sometimes is the best thing, because that means the code ran, right? Like, I didn't tell the code to stop. I didn't tell it to do anything. But now, even if I wanted to like get in here and pry in and see what's going on here, now I can get in here and I can say, okay, like, what is instructor 1? And it is indeed like an object, a Turing instructor object at that point.
How
So,
did you put that pry in so quickly? Like, was there a shortcut for that?
yes. So this is actually a snippet that you can define in Atom. And I'm not going to show you all how to do it, but just know, like, here's what I would Google, like snippets Atom. And that's like, you can define basically little blocks that I type in pry and I hit tab and boom, I have like the, you know, this is very hard to type, right? Require pry semicolon binding.pry. There's a lot of room for error there, right? But if I set up a snippet, now all I do is type pry and tab and boom, it's there wherever I want. So snippets, similar to shortcuts, but you define them is the cool thing about the snippets.
Thank you.
Yeah, absolutely. All right, so what do I want to do here? I wanted to show you all that example, and then, yeah, I told you I was going to build a dog class, so that's what I'm going to do. And I need to get, transcription is getting in my way. I think I can probably just do, yeah, it's a little bit better for me. And if y'all can't see this, let me know, but I think like this is where I'm going to have to have it so that I can navigate and see everything I want to see. All right, so I'm in this directory. I'm going to create a dog. Cool. And let's see, class is dog. The one thing that I didn't say is the syntax for like having all capital letters in this like Turing instructor example. This is called upper camel case. And then I obviously didn't mention the end. Anytime you're defining a class, you need an end as well to like let Ruby know, hey, this is where the scope of the class ends. Cool. I'm probably not going to use that runner. All right, so I got this class, and here's the thing that I want to do. I want to give me 2 dogs. Dog 2. All right. I want y'all to have the same thing on your screen. And so type this out. And here's what I want you to tell me. What's the difference between dog 1 and dog 2? How do you know there's a difference? And if you don't know there's a difference, then how could you find out what the difference is? So I'm going to type that. I'll put this in the chat and then give you all a couple minutes. Okay, so I put those questions in the chat. Let's take like, I don't know, 3 minutes on this one. Type this stuff out and yeah, we'll go from there. All right, I'd love to hear from some of y'all. Yeah, any of these questions that stand out to you that you want to answer, I'll kind of open it up to y'all to raise your hand and let me know what you're thinking. And here's another thing. Don't be afraid to offer the wrong thing. Offering the wrong thing is like one of the quickest ways that we can get to the right thing. Cool, Kevin, go ahead.
Yeah, so the difference between dog 1 and dog 2 is that they are just 2 separate instances of the dog class. So they're 2 different objects.
Love it. Sounds right to me. Cool. I guess I'll follow up with you, Kevin. How'd you know that there was a difference? Like, did you do anything? Do you just kind of know based on like theory, or did you like kind of like do anything to find out that there's a difference?
Yeah, so I knew off of theory. I mean, we are naming dog 1 and dog 2 to be a new instance of the class, but I believe you can run in Pry or in any like IRB or anything. You can run and see different variables for each class as well, I believe, or instance rather.
Cool. Okay. Yeah, I think you're on the right track there. Isaka, what are you thinking?
So the reason they are different because when you look at the instant variables, dog 1 and dog 2, it basically means that there are 2 instances.
Totally. Yep. And so one thing on technical language, I just want to point out there. So you said when you look at the instance variables. So in this actual example, we don't have instance variables yet. We have what we would call local variables here. And an define would be prepended with this act. And we would actually define that within the class, which I'm going to do and show you an example of. But I just wanted to be clear on that, like technical language, like what dog 1 and dog 2 are right here are local variables, what we call them.
Mm-hmm.
Instance variables always prepended with that act.
Got it.
Cool. Yeah, Laura, go ahead.
So another difference is that they have different object IDs. So if you run them in Pry, they're going to show 2 separate number sequences. I'm not really sure what you call that.
Cool. What we have here, dog.rb. Oh, yeah. Okay. Maybe that's actually a good thing to show here. I'll do this one more time because this will probably happen to y'all. So I ran this and then I noticed like it's not showing up the way that I want in Pry. This will happen in your terminal. And so I have some options here. I can simply hit the Q key. And if I hit the Q key, my like prompt appears, which is just like something you have to know. So if you see like, hey, And all that means is like the terminal is not big enough to show you the entire output like it's trying to, and you can hit Q to immediately like get to the point where you can type commands. Another cool thing that you can, and that's just because my terminal was so small, like that won't happen if I make the terminal bigger, right? Like if I do this, now my prompts are automatically showing up because the terminal was big enough. So just like a weird kind of quirk thing to know. Yeah, and so following up on Laura's point, yeah, so one of the things we can do on any object, or really any instance, I should say, is it's always going to have this like object ID that I can look at. And this is basically something happening kind of under the hood, and it's how Ruby is like remembering this object for you in memory. So that's all you really need to know about it right now. But if I look at that compared to dog2, like those are different numbers, and you can see the sequence. It's like looks like 4260, 4240 is like where they change. So not a big difference, but a difference nonetheless. So that's a great way that you can be like, hey, is this object are these the same or are they not? They're always going to have a different object ID. Okay, Tanner, what's up?
So I was kind of piggybacking off of kind of what Laura was saying. I was doing for seeing if they were the same. I just did in my file. I puts out like a equality comparison between dog1 and dog2. It goes out false. So
Yeah, so you did something like this. And this was the other thing that I was hoping that you would like know to do. So you can compare the two, right? We have this comparable double equal sign that we can use to always kind of like check and see if these are the same thing, right? So if I wanted to say like, if I wanted to see that these are the same thing, yeah, if I compare dog2 to dog2, then it's true. So cool. Rowan, go ahead.
Do you have any idea why the pry wouldn't be running when I run the dog file in the terminal? It just does nothing for me.
Yeah, I mean, let's do a quick debug here. So I'll stop sharing, and how about you share? Cool. That looks good. Interesting. Just not, my only thought is that it's the files possibly not being saved. Do you have autosave on?
Oh, I've been saving it. I just don't have the blue dot. So
Oh, okay, I got you. All right, so let's
Yeah.
just run it one more time to check my assumption there. Interesting. Okay, so that tells me that maybe like, oh man, I'm not sure honestly on this one. This is weird that it's not showing up for you.
I can figure it out later. It's no big deal. I just didn't know if you happen to know.
Yeah, I'm not sure. Like my guesses are like pries. Like, can you type pry in the terminal here? Okay, good. And yeah, I'm not seeing anything. How about this? Let's do something else. Let's put the pry. Let's exit. Cool. Let's put the pry in between 6 and 7. Cool. Interesting. Okay, so we hit it. And this is like something that I forgot about, honestly, but like, I don't know why this happens. Sometimes like if it's the last line of the file, it like won't get picked up. And like why that happens, it's just like a quirk. So what you could try to do is like create some more like new lines like towards the end, if it's like the last thing in the file that's running, like the require pry. So like we want it to be, the last thing that hits. So let's do this. Let's exit out of the pry session. Okay, and so what you can do to actually move a line, so if you go to line 7 and just put the cursor anywhere there, and you do command control, and then you can hold those down and use the up and down arrow. Yeah, exactly. So now you just move that line around. Let's try and like put a line between, like, let's put some lines between the dogs and the pry, basically. Yeah. And then let's just make sure that there's a couple new lines like at the end of the file too. All right. And let's just see like if that helps out some. I feel like when these like weird like little things happen, it's just like not fair to y'all. So I want you to be able to see like it's not you. You didn't do anything wrong. It's just still not running. Yeah. It's a quirk. I'm not sure why this is happening, to be honest. You didn't do anything wrong. The pry should be working. It's just like deciding that it doesn't want to. It's not hitting it. I don't know. It's like done executing there. What you could do is like basically you can create a different file and like just hope. Actually, I don't know if we saved, because I see the blue dot still now.
I have been saving it, but every time I save it deletes the new lines.
I see. Interesting. Yeah, weird quirk. I think if this stuff like happens, it's like just try something different. Like maybe like delete this file and like recreate it and see if you can basically like just get this. I would say like when there's not that much code like there isn't here, like delete this file, recreate it, see if it happens again, like because it's a weird quirk. Or you could create a different file, like in the example in the lesson, like the runner file you could create, and you could require the dog class, and then that's like another file that you're running. But what I'll say is like, you didn't do it, like this is weird, and like this should not be happening. So yeah, that's all I got for you.
Cool, thank you.
You're welcome. All right, I think we had another hand come up possibly, and then go back down. Ooh,
I got a quick question. I think that other hand disappeared. When we ran the pry through just to see if dog 1 and dog 2 were different objects, and it spit out those numbers, I noticed they were 20 apart. I'm just like wondering where that number comes from. I know it probably doesn't matter. I'm just kind of curious, like where the heck did they get that number?
Yeah, so when we created these instances, there's a lot of things that happen under the hood. The object ID gets assigned. It gets assigned a place in memory. This specific instance gets assigned a place in memory. And then this object ID is essentially how like Ruby under the hood is like looking up this specific object.
Now, is that specific to just like you running it?
No, this is like a Ruby thing. So this would happen like you would if you did this and like you looked at object ID, then you would see something, probably a different number, but that number gets assigned like once you create the instance, that number is assigned. And now it's like a key where Ruby can now access this like quickly based on this specific key whenever it needs to. But this is like computer science, like part of the Ruby language that's like abstracted away from you, that like we don't necessarily need to like know right now.
Yeah. Okay.
Yeah. Cool. I think I heard one person come off mute.
Yeah, that was me with the hand earlier. It wasn't really a question, to be honest. I just thought it was kind of interesting, like how everybody was arriving at answers like a different way. Because like, I don't remember who brought up the object ID thing and everything, but like I would have just used P.
Yeah.
Which you can just like look at the raw object that way.
Totally. So you would have done something like
P and then one of the variables, and then you can compare them that way. Yeah.
So this is another good way that you can do it, because it's like immediately giving you output in the screen, right? So this is a great way where now I don't need pry, right? Like the pry basically is the great way to stop execution of your program, look around, right? Be in your program, be in the state of wherever you put the pry, take a look. P is like executing the code and outputting to the terminal here. So if I run this now, yeah, now you can see like, hey, it's dog. Then there's this like long like group of weird characters, which are also like pretty similar, but down here, they're different. And this is like not the object ID, but like some other representation of the instance, of the specific instance here. But yeah, you can see that they're different here. Cool. Let's go to Erica.
I was going to ask if the object ID is the same as an object location.
I don't know, to be honest. It's an ID, but like where it's stored in memory, I'm not sure if like I'm not sure if it's the location, to be honest. I can like do some do some deep diving for you and get
Google
back
and I can have a conversation about it later.
No, but this is a good question. Like I don't have like it's good for y'all to see, like I don't have this like low level understanding of like how Ruby is like storing things in memory, because I've never had to, like I just haven't like run into that problem before where I have to like go solve that. But like it is defined out there. Like I know I could go look it up. This is kind of like what I want y'all to know. Like I could go look it up and then I would know, right? And you can do the same, but like, yeah, it's not something I've had to like keep in my mind. Cool. Matthew, go ahead.
So I did the P method as well. And I noticed like each time I run the file, I get different results back. It keeps changing.
That is interesting. Yeah. So that's a great point to bring up. And so what that tells me is like, every time we're executing this, what's happening is a new instance of dog is being created. Those same instances that are created, like every time I run the file, basically what's happening under the hood is Ruby is like, okay, execution has stopped. I am cleaning up these objects and discarding of them. And now when I execute the file again, it is creating a new one. And then literally like as part, it's all of this stuff is like abstracted away from y'all, but that's what's happening is like essentially like those objects that get created then immediately get cleaned up because they're not being used by any other part of the program. Like execution of the program stops, we're done. And it's like, okay, see you later. And now whenever we run it again, those are new objects at that point for the new like execution that we're doing.
Good to know.
Yeah, absolutely. No, thanks for the questions. I think this is like interesting things for y'all to like be thinking about, but like not necessarily stuff you got to know right now or ever. Like as long as you can look it up, it's kind of like that's like one of the things about programming that's kind of hard to decide, and that's why we, at least in this program in Turing, like decide it for you. Like we'll tell you like what you need to know, and then there's a ton of shit that you just don't need to know that you can like look up, and that's like going to be the same throughout your career, right? Like there's going to be stuff that you just need to look up, and that's okay. Cool. All right, let's take another break. We'll come back at 5 and we'll get into some attributes and methods. Okay, it's 10:05 Mountain Time. Hopefully it's also 05, whatever time zone you're in. Yeah, cool. Michael's got a question for us.
Yeah, I was just curious, like, what is the Atom package that you have installed that shows like the little icons for like your Ruby files on the left there?
That's a great question that I don't know if I know the answer to. Packages. You installed packages. There's a lot of them in here. Yeah, linter. I don't know. I would Google, like, I've just had Atom for so long now that like I've installed these over like, you know, the last 4 years. So I don't necessarily remember, but I have quite a few. And like packages, the idea behind them is like, they're just like helpful, right? They just make your experience a little bit more helpful. So I encourage y'all to like think about like which ones you want and which ones like are helpful to you. Like bracket highlighting was helpful to me at some point. Yeah, shortcuts, whatever. Oh, here we go. File type icons. That's what it is for sure.
Cool. Thanks.
Cool. Yeah, that's nice. Gives you the little Ruby because it's a .rb. Okay, so let's get into this. So we kind of like noticed like, yes, there's a difference between dog one and dog two, but like there's not anything like different about these objects except they have different object IDs, right? Like we haven't like given this dog a chance to be unique, right? And so before I give it a chance to be unique, I want to tell you about a beautiful and useful method called initialize. So initialize is essentially a method that, let's see, okay. So initialize is essentially a way for me to like decide, hey, when dog.new gets called here on line 7, I want this block of code to execute every single time I do I create a new instance of this class. I need some code to run, and that code I would put in initialize. All right. And so I'm going to actually get rid of the argument here. And yeah, let's just make this like this. All right. So initialize can take arguments, as you saw, like that's kind of like my default tab complete that I have there, but like it also doesn't have to, right? Like it just can run here without an argument. And if I want to see what's going on here, I can do like a P. Actually, we'll do a puts here. And I'll say like this runs every time we call .new on our dog class. Great. Now, if I execute this file, cool. It ran twice because it ran once for line 7 and once for line 8. Those are the two objects I created. So initialize essentially ran twice, printed out that line for each time. All right. Cool. Questions about initialize, just like initial questions about initialize. I got one laugh, so that means it was a successful joke. Thanks, Laura. All right, doesn't look like we've got anything right now, so I'll move on. Yeah, so in general, what we want to do with initialize, or in general, what we want to do with initialize is basically define some state for our class. We want a way for our initialize method to give our objects a way to differentiate themselves from one another. So let's do that. What's a good attribute that I can assign to a dog? Anybody got something?
Breed.
Cool. Breed. I've got some other hands up. Isaka, what do you think?
Name and age.
Name. Cool. Age. Love it. Andrew, got something else?
Weight.
Weight. Great. All right. So I think that's enough to start with. And so I essentially can do a couple of things here. So I've got my instance variables. And so the reason I define these as instance variables is because I want these variables to be unique to the instance of the class. And I want them to be accessible at other points within the class. So that's why I define them as instance variables here. If I define them as local variables, the rest of my class would not have access, or I should say the rest of my instance would, the methods in other parts of the class would not have access to these unless they're instance variables. If I define them in local variables, then only my initialize method will have access to it. So I'm kind of planning ahead for other methods within my class to have access to this instance variable. Ida, go ahead.
So that at symbol, that's what marks it as an instance variable.
You got it. Cool. Itsuka, what's up?
What about if you want to use these instance variables in a different class? For example, if we create a cat class, right? And
Yep.
we want to use some of these instance variables, how do we do that? Can we use them?
Yeah, so that's a great question. So you would, what you need to remember about instance variables is they are specific to a specific class. So yeah, you could do that for a cat. but like those would all be specific to the cat class, just like these are specific to the dog class. And like there is a way that you could like give all of these. Basically, the short answer is you could use inheritance to define all of these
Right.
at a higher level and then pass those down to the dog and cat, but that's a little bit beyond the scope of what we're doing today.
Yeah, I think I'm asking because I'm doing the flashcards project, and like there are like sometimes you have to pull an instance variable from a different class to use to compare. So I'm just trying to figure out how it works based on the example that we're learning here.
Yeah, I think we're gonna get there.
Okay.
All right. Any other hands? Any other questions right now? Okay. Cool. So, Ida, do you have a question? Sorry, I just lowered your hand.
No,
so
I have a terrible control over that hand.
Okay, no worries. Cool. All right. So now I've got these instance variables, but I have to assign them to something. And like what I could do is I could assign them right here. And I could say like, okay, for each dog, they're going to be pit bulls. Their name is going to be Frankie. And their age is going to be this age. We'll make it a float. And the weight is going to be like 60 pounds. Well, let's just make it 60. I could do this, right? But now the problem with this is I have this dog class, and I mean, clearly it's by far the best dog class it could be at this point, but I don't give this class any way to be different because I have hard coded these values. So every time initialize runs for dog 1 and dog 2, and we can kind of like see this. Like, actually you can't see. Well, yeah, actually when I look at it, I'll be able to see dog 1. Great. It's got all these attributes. That's nice of Pry to show me all this stuff. Dog 2, same attributes. So the way that I need to make this class dynamic is I need a way to pass in attributes that are different for each dog. All right. And so that's what I'm actually going to do here. Let's do that. Oh, that's a weird quirk. All right, and I'm going to say initialize takes some arguments. And so there's going to be like this difference between arguments and parameters. And I think you probably talked about it a little bit yesterday, but I'll just redefine it. So when I am defining it right here within the parentheses, it's a param. All right. So I'll call it that. Name param and age param and weight param. So here it's a param. And basically, I'll tell you when it's an argument, but this is going to be assigned here, this here, this here, and this here. Cool. Okay. So these are going to be assigned. So now, because I have this class set up in a way that it assigns the parameters here, now what I can do is I can pass them in as arguments. And that's really the difference. When you're defining them in your class, they're parameters. When you're passing a value into them, they're arguments. All right. So that's like the real difference in syntax there. And so now let's pass this in. Pit, Frankie, and what is she? 1.5. And yeah, now this is going to be 60. Cool. So now I'm passing these in as arguments, and I can do the same thing here for dog 2. Might as well show y'all what the error is here because you're going to run into it. So if I run this file, wrong number of arguments, given 0, expected 4, argument error. And that is on, it says it's happening on line 2, but if I look at my stack trace, and many many more of these to come, like much more on error handling and error reading to come. But I can see on line 11 is kind of like where it's like telling me that this is happening. I just didn't pass in any arguments here. So it's telling me like, hey, based on the way you defined initialize, we expect 4, you gave me 0. So something to note. All right, let's do another dog. Raise your hand if you have a dog and you want to tell me about them. Ida, go ahead.
The breed is an Akbash, AKBASH.
Cool.
And the name is Casio with 2 S's, CASSIO.
Cool.
And the age is 2.25. That work? Okay. And the weight is 95.
All right. A big girl, a big boy?
Boy.
Big boy.
He's
Okay, cool.
behind me.
Awesome. Hello, Casio. You have been injected into this class. All right. Now, a couple of things I did here. So I kept all of my my arguments the same data type, and I didn't have to. Ruby would allow these to be different data types if I wanted them to be, but like we shouldn't do that. Convention says, hey, let's make sure all of the data types are the same. So string for the first 2 arguments, float for the 3rd, integer for the 4th. Just wanted to point that out. And then, yeah, let's run this. Cool. I hit my pry. I look at dog 1, that's Frankie. If I look at dog 2, that's Casio. Great. So now I've finally given my dog class, and I've given myself some ability to be unique, right? Via attributes, via instance variables. Like attributes are the way that we hold state. If we kind of think back to the state, that like what are classes for? Defining state and behavior. Attributes are our state, and behavior is how we generally change that state and adjust that state or perform some task that our class is responsible for performing. Questions right now? Yeah, go ahead, Laura.
Can you say that one more time? You said states are the attributes, and then what changes them?
Behavior or methods.
Okay.
Yeah, methods usually define our behavior.
Thank you.
Yeah, absolutely. Okay, I think I want y'all to have a chance to do some stuff. So let's do this. I'm gonna put y'all in some breakout groups, and what I want you to do is define 2 things. And where I'm going to point you to try to do this is the lesson plan. It's not the same, but essentially, y'all, we have this dog object, and like your object doesn't have to be a dog, it could be something else. But the things I want you to do is access an attribute via an instance method, and then change an attribute via an instance method. Okay, now you might be looking at that and say, like, we haven't not learned how to do this yet. And I would say that is correct. And where I want to point you is the lesson plan and to your teammates who will be in the breakout room with you. Go ahead, Caitlin.
I was just wondering, in the lesson versus what you've been working on, you had your class in a separate file versus the instances. Is that normally how you would set that up, or you want to keep everything together?
You can do it either way is the shortest answer. Like, you don't have to keep everything together, but like in general, I guess like for the sake of today's class, it's not that important which one you do, but in general, where this end happens here is the end of our class file. So like, I wouldn't usually have like this stuff. I'm just like using it for examples. Usually I would have the runner example, like from the lesson plan, where like you have this other file, you require in the classes that you want to make. And then the runner file is like the execution of the program. Basically, I've like combined the two, where it's like, you can think of like right here as the program running, and you can think of right here as the program being defined.
So on the project, anytime we see that require, it's just referencing to that class file we created.
Yeah, anytime you see the require, that's basically giving whatever other, like the different file that you're in. The require is saying like, hey, for my program to run over here, I need to like bring in this file. And that's what require does, is like brings in your access to like what was defined in that file. And I kind of glossed over that today just because it's like, it's less important than kind of like understanding like the core elements of classes and instances.
Okay, thank you.
Absolutely. Isaac, go ahead.
I'm just trying to understand, we have for this dog class here, we have initialize method, right? So
Yep.
how is that different than attribute reader and attribute assessor? Like, do we still need the initialize method if we have attribute reader or assessor?
Yeah, so the big difference there is attribute reader gives you the ability to access an attribute, but initialize gives you the ability to set an attribute, right? So reader is essentially saying like, here, like I can show you what this value is. Initialize is where we're setting that value. Like we're assigning that value on lines 3, 4, 5, and 6 here. Is where we're like us doing the assignment, and that happens right at the big, like every time I create the new instance, boom, initialize runs, those attributes get set. Later on, when I want to access those attributes, that's where an adder reader comes in.
Okay, and assessors are getting, right? Readers setting, like that
Other
setting
way,
and getting
other way around.
the other way.
Reader
Okay,
is
and
getting, reader is
when do
getting,
we? Okay, and when do we use that in a class?
generally you won't need to use accessors. This is kind of like beyond the scope of today, to be honest. It's like you should be able to define your class in a way that you only need to use readers. Accessors are like if you need to change something, if you're basically, accessors are dangerous because you're allowing other parts of your program, other classes, to change the state of a class that they don't own. So I would say like for now, and for the sake of this entire mod, honestly, just use readers.
Okay.
Yep.
Thank you.
For sure. All right, Ida, go ahead.
Just to go back to what Caitlin was saying, are we going to be learning how to get to another file or access another file, because we need that for the project? So when are we learning that?
It's all coming. It's all like happening. Like, yeah. I think like what I'll say with that is the way that you access another file is by requiring it. And like that, there is an example in the lesson plan. I just like didn't go over it today because that's like, it's outside of the scope of like what you need to know today. But
okay,
the way that you access another file from a different file is with require, and like you can kind of like look up how to do that.
okay.
Yeah. Cool. All right. I got some breakout rooms. Well, let me create them. So you should have either 3 or 4 of you in a room. And the idea here is access an attribute via some method that you define. Doesn't matter to me how you define it. And then change some attribute via an instance method. All right. And if you want to use like the runner example and like do it all in the runner, that's fine. Or if you want to use it or do the same way that I'm doing it here, where I've just like kind of combined the two, I'm taking out the need for you to like require anything here, because within this file, we already have access to the dog class. So that's all I want you to do. I think we'll take like 8 minutes on this and then we'll come back together. So So plan on coming back at 34. Y'all are in these breakout rooms so that you can like talk, but I want everyone typing on their own machine. Cool. Back up and stop sharing real quick. All right, does any brave soul want to show me what they did? Could show me if you access an attribute or if you change an attribute. Yeah, Matt, go ahead.
Share. So we made a favorite food empty array. We made a name method that just accessed the name instance variable, and then we created a method that pushed a food. I don't know if you want me to use the word parameter or argument into the favorite food.
Well, I appreciate you being kind of like focused on using the correct technical language. I could tell you were definitely focusing, so I appreciate that. I think like in this example, you like either would work because you could call like essentially what you're pointing at is the parameter, but like what is actually passed in will be the argument. So in the case of you explaining it, either would work there. Cool. So let's actually like build on this a little bit. So there's a couple things that I like, a couple things that I want to point out. All right. So you've also defined 4 other methods at the top of the class in line 3 that are name, age, fave food, and breed. And so what I want you all to know is the way that Matt has defined these adder readers, essentially lines 12 through 14, where he's defined that name, which returns the instance variable, is exactly what an adder reader does. So what him having name and then this like name method from 12 to 14, those are the same things, and we don't want to do that. All right, so we want to choose one way of doing this. So yeah, I would say like, yeah, you can get rid of that. And then the other thing that I would say is, so because you defined fave food as an adder reader and an instance method, Ruby's going to get confused by that. So yeah, I would take it out of that instance method. Yeah, and remember to never leave a trailing comma. So great job there. So now what you've done here is you've defined methods called breed, name, and age as adder readers. And just to bring it back, I want you to know that the way that name was defined before is essentially exactly what's happening by defining it as an adder reader. All it does is give us method access to whatever the value of the attribute is when we call the method on it. So now what I could do is, yeah, you're already in a pry session. So this is cool. You've got this fave food. I think we should just talk about what happened on line 2 of the pry. So you essentially did dog2.fave food and then passed in steak. What happened there is steak was then passed into my @faveFood instance variable. And if I want to see that, what I could do here is I could just type in dog2. Yeah, let's just look at it this way, because this isn't going to be an interesting case. Okay, I can't see because of the transcript. Do you mind just moving it like up a little bit more? Yeah, thanks. Okay, so you can see like fave food, indeed, it's an array that now has steak in it because we passed in steak and now we've changed the state of this array, right? Like we've passed in a string of steak and now our state of fave food is different. So what do I want to say here? We want to do a couple of things here to make our class more efficient and more changeable. So we still need a way to access this fave food attribute, but we basically have gotten rid of it by getting rid of that adder reader. So what we're running into here is we have like a little bit of a name collision between what you've named this method on line 12 versus what you've named the attribute. And what I would say is, I like what you did on line 12. I just want the method to be named something different than the attribute. So let's say we call this add fave food. Cool. Now what you can do is you can for your adder reader, instead of deleting fave food, we still want to be able to access this. So let's add it back. So now we have a way to access our array via the method syntax of fave food, and we have a way to add to that array via our method called add fave food. So we have a way to check our state by calling .fave food, and we have a way to change that state by calling .add fave food and passing in some argument. Okay, I've been talking a lot. I know there's some hands. Matt, can you continue to share?
Oh, sure. Yep. Sorry.
I think it'll just be easier to kind of like stay in this context. Okay, Rowan, go ahead.
I just had a question. Why are the instance variables symbols in the adder reader?
Yeah, that's a great question. So that's like convention. That's convention for Ruby. It is like those look like symbols, but they are methods. And this is confusing. I'll just go ahead and say it. Like, especially when you're first starting out, like, yes, those look like symbols, but what they represent are methods because of that adder reader keyword. Because you have the adder reader before them, they represent methods that essentially work the exact same way as Matt had it defined before. And Matt, can you just like do that method syntax that you had for name up in the class? Because I just want to show this real quick. So if between like, if you go to like line 11, and we just define a method called name. Sorry, you're good. You're doing great. Cool, and let's end that. Yeah, or yeah, you can put at name in there, because that's what I want you to do. And then end. Yeah, okay. So essentially, what's happening on line 12 through 14 is the long syntax for what the adder reader definitions give you. So because you defined adder reader, symbol breed, symbol name, like those, you can think of those as all like different methods that you're defining. And what they do is they return the instance variable of the same name. The same way that lines 12 through 14 would work. That is literally exactly how the adder reader works. And the adder reader is just like shorthand syntax convention. Okay, so I want to play with this program just a little bit more. So let's delete what we just did. Or you could even comment it out if you want, but yeah, whatever. All right, so something to note, when you're changing things around in your class, but you're in a pry state, pry only knows about what your program looked like when it initially got ran. All these changes that we have made so far, it doesn't know about. So yeah, we need to like restart this pry session essentially. And so that's what Matt's doing here. And so cool. Now what I'd like to do is, yeah, let's add a fave food. So let's add a fave food to dog1. Dog1 dot add fave food. Yeah, and let's give it like biscuit or something. Great. Now what we can do is, so what you see here is you see the return value of add fave food, which happens to be what this array is here. So that's what you're seeing there. But the other way that you can kind of like see like what at fave food is at any point. Now that we've defined it as an adder reader up top on line 3, now you can call dog1 dot fave food. And that will give you the return value of what the current status or what the current state of that array is. Same thing for like age. Like let's hit it with dog1 dot age. Actually, that's probably going to be nil at this point. Or no, it should be good. Yeah, 1.5. Sorry, I was misreading it. And you can now, what you've done is you've given your objects a way to return their state at any moment via calling a method on that object. Kelsey, what's up?
So if I called fave food on dog2, would it come back as nil since we haven't put anything in there?
That's a great question. Let's find out. So yeah, let's see what dog2.fave food is. Yeah, so it's not nil because
An empty array.
Yeah, go ahead. Yeah, it's an empty array. And the reason it's an empty array is because remember when we called dog.new and passed all of those arguments on line 18, initialize ran, right? And it ran for dog2 this time, and we haven't changed the state of dog2. So on line 9, when initialize runs, it automatically sets the state of fave food to the empty array, and that is indeed what we have here. So now you're seeing like the power of having different instances who also have different state, right? Which we can modify via our behavior, and our behavior here is add fave food. Great. Okay, Matt, you're off the hook. Thanks so much for sharing. Cool. Okay. So where are we at? How are we feeling? I guess we could do a show of hands. I'll ask some questions and you can give me a yes, no. If you go to the reactions, I think, yeah, you can give me a check mark, a green check, or a red X, and either one is fine. Like, I feel comfortable defining attributes in a class. Cool. Okay. I understand how to access the state of my class via a method. Cool. I understand how to change the state of my class via a method, and I feel comfortable writing the code to do so. Cool. Cool. And this is kind of what I expect here, as to be like, all right, some are comfortable, some are not, and that's okay. Like, that part of what today is about is introducing you to the concepts, giving you some examples, and then kind of like seeing what sticks and what doesn't. And when it doesn't stick, it's the simplest answer is it's more time practicing. So that's what I'll say there. Okay. Yeah, we've got some hands up. Ted, go ahead.
So I never, like, when you do testing, we haven't gotten there yet, but like you can pass stuff through food, like we were looking at earlier, like that method. But if you're just given the class and that information we have right there, how would you pass something into food when you're initializing, or not initializing, we're creating an instance? If that makes sense, or like an object. So how would you do that?
I'm
Just,
not
oh no, my
totally-
bad. It would just be, never mind. It's actually dumb. It'd be like, whatever it was. I forgot what the object was. Dog1 dot the method, and then you put in the food in there, and then it would spit back out, right?
Yeah, so you're, okay, now I understand what you're asking. So, and not dumb at all. So Matt, can you share just one more time, just because I think it'll be easier to see it? Awesome. Yeah. So essentially what we did in Pry, we could also write here. So let's do that. Let's copy and paste what you did on like line 1 of that Pry. Yeah, so we don't want the whole Pry thing. Just start at dog 1 and then kind of move to the right, and then copy that.
Am I getting what you want?
Well, let's just paste it into the file.
I'm not quite following.
Yeah, so I think you copied line 1, right? Did you do a Command C there when you like copied it all? Cool. So
Yep.
now let's do a Command V in this dog file, like where, like right above the Pry, basically. Cool. So let's get rid of everything from the caret. Yeah, back. Cool. All right. So this is essentially, we did this in Pry, but like you could have this run as part of your program. And essentially all we did is we said, all right, I need the instance of dog 1. And then what I need to do is I'm going to call a method called add fave food and pass it the argument of biscuit, which the way that that method is defined here populates my fave food array by shoveling in that argument into the fave food array. And I could call this as many times as I need to, right? So let's do, so this is a fun shortcut, Matt. So if you put your cursor on line 20 and you do Command C, then Command V, it just copies that line and you don't have to like do anything else. So yeah, let's just like put a different one in. And essentially we can keep populating this array. Let's put steak back in. Great. And we can just keep populating, like we can do this as many times as we needed to and add things to our array. And I'll show you that this is actually happening if we exit out of this and then run this program again. Cool. And yeah, let's look at dog 1 dot fave food. Now you can see fave food, because we added all of these on lines 20, 21, 22, populated that array with these string values that we passed in as arguments.
Thanks. Yeah, I've been doing a lot of testing stuff lately and I just forgot that, I guess.
Oh, no worries. No worries at all. I'm glad you asked. All right, Isaka, what's up?
So based on Matt's code here, could you give us an example as to how to use an instant variable from this class in another class?
Essentially, if the other class has access to the object, then we could, the same way in Pry, like we are calling dog1.faveFood, if we passed an instance of dog to say some other class, then as long as we're holding on to that instance within the other class, because we've defined these adder readers this way, we can still call dog1.faveFood in that other class. Because
sure, but when I have done that, it showed an error, a method error. For example, for this one, right? If I have another class called class pig, right? And I wanted to compare their the age of a dog from the dog class to a pig from the pig class. How do I pull the weight from the dog class to use in the pig class?
Yeah, that's a great question. How about this? I'm going to show you an example. Okay. Let me, because I was planning on kind of doing this already, but I think that this is a good place to transition. All right, so essentially I have this dog, right? And what I'm going to do is show you how you can access any of these params, or I should say any of these instance variables in a different class. So, all right, I have this runner file here, and essentially what I'm doing is I'm bringing in class example. I kind of want to change this to Turing instructor. And what I'm going to do also is I'm going to change the name of this file to, hold on one sec, let me get this out of the way. Hide controls, cool. To Turing instructor .rb, or shoot, I just accidentally created a new one. That's fine, I won't, I'll just bring this over. All right, so I have this Turing instructor class, and essentially what I'm gonna say here is when this class is initialized, what I want to pass it is a dog. All right, and I'm going to pass it a dog object. And essentially, we're just going to assume for the sake of today that, hey, every time a Turing instructor is initialized, they always have a dog, and which, you know, checks out from Megan, Mike, and I. So I'm defining some new state in this that a Turing instructor will have a dog. So now if I want to say like, let's call this a method. I'm kind of dream driving what I want to happen. So I want to say like print dog name. And what I'm going to do here is I'm going to say, all right, I have access to @dog. Let's call dog.name down here. And since I'm going to print it to the screen, let's say that this is a puts. Cool. So I'm dream driving what I want to happen here. All right. And let me get the runner file up so that you also have this example. Essentially what I'm doing here is I'm giving this runner file some access to my other files that I've defined. All right. And so this is where the magic's going to happen essentially. And what I'll do is I'll take what I already have here from dog. And I need to have a dog object initialized before I can pass it to a Turing instructor. All right, so essentially you can think I just copied and pasted these two lines. So the first thing I'm going to do is create two dogs, same two dogs we've been working with, right? And then the next thing that I'm going to do over here, I look at Turing instructor, I'm like, okay, Turing instructor needs to be initialized with a dog. So now what I'm doing, and we'll just say this is Tim because that's my dog. I'm saying, hey, I have this object up here, dog1, and I'm going to pass that into initialize so that my Turing instructor holds on to a dog object. All right. And now we're going to hit a pry and look around.
You spelled your Turing instructor file wrong.
You hate to see it, but I appreciate that. I obviously can't find or don't know how to spell instructor. Okay, so let's get out of this. So now the file that I'm going to run is going to be my runner file, because that's the file where all of this essentially magic is happening here. All right. So let's run this. Great. I hit this pry. That means things probably went okay. Let's look and see what Tim looks like. Cool. So I have a Turing instructor object that is holding on to a dog object that is defined. So the instance variable @dog within the Turing instructor class holds on to the entire dog object that I created up here on line 4. So I've essentially just passed one object to another object. This is like core fundamental idea of mod 1. And this gets back to what Isako was asking, like, hey, like if I'm not in the dog class, how do I access something on the dog class? Well, oh, I haven't done it yet. So this is going to be good. This is actually going to be great to see. So because my dog class here doesn't have an adder reader or a method that I've defined at all for name, I expect that I'll get an error here when I call tim.printDogName. And my error that I expect to see is undefined method name for dog class. Cool. For realistically for the dog instance that Turing instructor holds. So what I'm going to do now is change things around a little bit so that this does work. So I hadn't defined a method called name on the dog class at this point. How do I do that? I just give it an adder
Attribute
reader.
reader.
Yeah, yep, you got it. I give it an adder reader of name. Now I've changed the state of this class, right? I've changed the behavior of this class by giving myself access to this method syntax. So now I'll run my runner file one more time. Great, I'll hit Q because it's too small right now, but I can hit Q. And what I'll do is I'll run the exact same thing that I ran before. Tim.print dog name. Cool. Interesting. We get 2 values back here. Frankie gets printed to my screen. Great. That's what I expected. And then nil is returned. This is like another quirky thing that you kind of just have to know in Ruby. The return value of a puts is nil. So puts prints to the screen, but the return value, like within this method, is nil. Something to remember, something to keep in mind. I could change the return value here, where I could say, hey, I want this to put the name to the dog screen, and I want my return value to be true. And I could define that just like this. I could just add a true to it, right? Remember, this isn't going to work in my current state of the pry, because pry only knows about what the state was when it ran, when it initially gets hit. So I can exit. Now, if I run the exact same thing, now Frankie gets printed to the screen, and true is my return value. So I've changed the return value here from nil to true simply by adding true as the last line of the method. If it's like this, then it would be nil because puts return value is nil. All right. I know we got to have some questions at this point. Yeah, we got 4. Good. Okay, Kelsey, go ahead.
Mine was kind of back when we were working on changing the favorite food, but
Yep.
Is that what you mean when you were talking about changing attributes earlier?
Yeah.
And like, if I wanted to say, my dog gained 7 pounds, like we had an add favorite food, so we had a place, like a method to do that. Would I need to then add like gains weight?
Exactly. Yeah. So we could, I'll even just draw this out for you so you would have it. So the weight is going to be an integer. So I could say like gain weight. And I could pass it in like this is going to be the amount of pounds, right? Let me make this so y'all can see it. And then this would be a little bit different. So I would want to take the weight that I currently have, and I would want to add, yeah, exactly, which like I can do with this kind of like shorthand syntax, this plus equal. So this adds the value and assigns the new value. And I could do this like amount of pounds. So now I have a method that can change the state of my weight here, which is, a very reasonable thing to do.
Okay.
Cool. Yeah, Erica, go ahead.
Sorry.
Wait, so sorry. Hold one sec. I heard someone say
So
sorry.
I'm sorry, that's just me again. Just going
Okay,
back to
what's
the
up,
question
Erica?
it was asking. So now that you explained how to use, these instance variables in a different class, but how do we use the method in a different class? For example, for the class, the dog class there, you just added a method, a new one, gain weight.
Yep.
And if we want to use that in the Turing instructor class, how do we do that? Is it the same?
It would be very similar. So I could
Way?
do, yeah, it would be very similar. So now in this Turing instructor class, I could say like def, dog gains weight. And I can pass in a weight here, amount. And now because I have access to this dog, I can say at dog dot gain weight. And I'll pass it the, amount, And so essentially what happens here,
And- Sorry. So, and do we have to add that to the attribute reader in the dog class?
no, because it's already happening, and like it happens in the dog class here. In the way this example, like the weight is being added to. So when I call dot gain weight here and pass it amount, this method runs within the dog class, and then we would see the dog's state of weight change to whatever I put in.
Cool, awesome, thank you.
For sure. Okay, Erica, go ahead.
I was gonna ask about the print dog name method. You have puts inside of the method. We were told yesterday that that kind of goes against convention, specifically because of the fact that it returns nil.
That's correct.
Okay, I just kind of wanted to confirm. So would then be like kind of the better way to take the puts out, and then when you're calling that method, put puts in front of the method being called.
Exactly. So it would be something like this. And then if I take out the puts, right? And now I hit this runner. And now I would want to do something like this, like puts in my pry session. Tim, what did I call myself as the instructor? Tim dot print dog name. Yeah, so exactly what I think like Megan probably told you is correct, right? Like this is a better pattern. You don't want to be necessarily putting stuff in your methods unless like the problem with that is you can't test them, right? Like I can't test what's being printed out to the screen, and all I get back from the method is nil. So it's kind of like not the best. I was just kind of trying to show an example, but yeah, thanks for calling me out. I appreciate it.
No sweat. I just wanted to check.
Yeah, for sure. Okay, we've been going for a bit. Actually, Jamie, what's up?
Can you just explain again, like when we use instance variables versus like a local variable? Because I think I get confused on when I need to use like @dog versus just like dog, not the method.
Yeah, that's a great question. So let me get rid of this current instructor. Let's get rid of these. Okay, so I think looking at dog versus the runner is kind of a good way to like look. Usually where we define instance variables is within an initialized method, right? So as part of the state of a class is where you want to use instance variables, because they are representative of the state of like specific instances of this class. So you define them here in this class, in the class, like, hey, this is where we're defining instance variables. Where you could use local variables is kind of more general. Like you can see that I have local variables here in my runner that I'm assigning, but I could also say like, say I had like some method here, and it's not necessarily related to like the instances, like it does something else. Like, let's just say like, what kind of variable do I want? Like, let's actually name this a little bit better. So this could be like multiply weights by 2, then add 10. Just trying to do something that will require a local variable. So it'd basically be like, okay, I need to access my weight, and then I need to multiply that by 2, right? So I need the instance variable here, but I can save this to a local variable just for now, right? So like this could be weight by 2. And now I just want to save this for the scope of this method, so that then I have my weight by 2, and now I know I need to like add 10 to it. So now I've used this local variable here to just hold on to like some state for like a little bit, and then add 10 to it. Then when this method breaks, I don't need access to this variable anymore. It's just for the scope of this method, just for the sake of doing this like one thing. So local variables, you can use like runner files is a good place if you're like running and you need to like hold on to something like over on the left, or just like within the scope of a method where you're like, hey, I need to hold some value for the sake of just this method, just for a short time, and even just to make this like more readable than it would be if I just did all the math like on one line.
Thank you.
Yeah, for sure. All right, we've been going for a bit. Let's take like 8 minutes and we'll come back at 17 and we'll get into some each.